Right, okay, so this binomial question is formula driven and it's not in the correct form for the formula at the moment. We need it in the form 1 plus x to the n. Alright, that's what we're dealing with. And it's not ready yet, okay? We've got to do an expansion just for the first three terms up to x squared. But we need to amend this to get it in the right form. So, to get it in the right form, we're going to have to factor out a 2. And then we'll have 1 plus kx over 2 to the minus 4. But when you factor out the 2, we also have to take out a minus 4 with it, okay? Then we are basically formula driven, aren't we? So the formula is 1 plus nx plus n minus 1 x squared over 2 factorial. But we are working within a square bracket for our version because we factored out 2 to the minus 4, which is 1 over 16. This is our 2 to the minus 4 here, out the front. Then we have got 1 plus, we've got minus 4 is our n, and our x is actually the k over 2, x. So k over 2x in this position here. Plus minus 4 minus 5, that's our n minus 1, over 2 factorial, so I'll put that out the front there, times by, and we're going to get this part here, I'm going to write up here, it's going to be k over 2x squared. Alright, and we know that we've got to square everything in the bracket. This is the problem area because sometimes we just write k over 2x squared here. That's not what we're after, is that we need to square the k over 2. So k over 2 times k over 2 is k squared over 4. And then we have our x squared. Okay? That's important because we've got to compare coefficients of x squared with this number here. This 125 over 32 is going to be the same as what we've written here and this 1/16. So we've got to set that up. 1 over 16, and I'm just going to copy in all of this again. So 1 over 16 multiplied by, well, I can work this out really. Minus 4 times minus 5 is 20, divided by 2 factorial, which is 2, plus the 4, which we had there, should have worked that out really. And k squared on top, k squared. That's our coefficient of x squared, and that is equal to what they've said is the final coefficient of x squared, which is 125 over 32. Stick this in a calculator, it simplifies down to 5 over 32 k squared is equal to 125 over 32, and I think the 32s are handy. You're basically going to have to divide by this fraction. This fraction is multiplying k squared, and when you divide fractions, I'm just going to do it side by, no, I'll do it underneath. So we've got k squared is equal to 125 divided by 5 over 32, which is the same as multiplying by the reciprocal. Keep flip change, if you remember that from GCSE. So instead of dividing by that, I'm going to multiply by the reciprocal of it. And the 32s are going to cancel out. And I'm going to get k squared is equal to 5s into 125 is just 1 and 25. Divide through by 5. K squared is 25, therefore k equals 5. And that is what we are after. Alright, so k is 5. if k is 5, then we can work out the value of a, because a is going to be equivalent to the coefficient of x here, which at the moment is just what we've got here, minus 4 times k. We know k is 5, right? Over the 16th, so we put the 6 times 16th on the bottom, and the divide by 2 here. So again, we're going to get minus 20 over 32 is equal to a. I mean, that's fine. We can simplify that. Divide through by 4 to get minus 5 over 8 is the value of a. There we go. Okay, and we just need to make sure that everything checks out with that. And it says, okay, so part B, this last part here, determine, giving a reason for your answer, whether the binomial expansion for f of x is valid when x is 1 over 10. So we should know that we need this part of our formula here to be less than 1, otherwise we get a sequence or an approximation that diverges rather than converges towards a result. So what do we normally say? That the modulus of x is supposed to be less than 1. Our value we have is in our position here we've got k over 2 is our x value. So we have in our modulus sign here, which is going to be less than 1, k over 2x is less than 1, and our k value is 5. So 5 over 2x is less than 1. So if I multiply or rearrange to get x equals, okay? Rearrange to get x equals, so we just need to times by 2 and divide by 5. So, and that's obviously going to give us 2 over 5 if we're doing it to 1. So this is our valid range, and it may be easier to think about this as something over 10. So this is 4/10, right? So as long as the value is less than 4/10 or greater than minus 4/10 because of the modulus sign, then it will be valid. So is 1/10 less than 4/10? Yes, it is. So 1/10 is less than 4/10 or 2/5. Therefore, it will be valid. Okay, I'm running out of space here, so write this in a nice sentence explaining what you've said, and that should be enough. Alright, I hope that's helpful. That was a tricky question. There were so many things that could go wrong. You're only using a formula and you're substituting into a formula, but you've got to be so careful when you're simplifying everything. That's where the errors were happening in when I marked it.